I won't say a welcome. I guess most of you must have followed what I said in the previous part. So still okay. Welcome all of you. And this part is going to discuss more about the theoretical properties of sets, some laws which are very helpful in solving and simplifying the sets. Like we have done addition, subtraction, multiplication for the numbers, we will be discussing more about the properties, what addition, subtraction which we have already done previously, what properties will help us in simplifying the different questions. And remember, De Morgan's law is the most favorite area where the question might come in your school papers, and it's also useful for JEE mains, as you will see later on in the question part. So let's begin with the part. Let us look at some interesting properties of the sets, and these results are going to be helpful in solving the questions. Venn diagrams we have already looked, but these are some algebraic results which might be helpful in the boards also. Plus in JEE mains, straight away directly the questions comes based on the properties of these sets. Okay, so if these are the finite sets and U be the finite universal set, then this relation we have already done, like through the Venn diagram. This was A, this was B, this was common. So if you, since these elements are repeated twice, so if we add these two, so these will be counted twice, and if we subtract them, we'll get the elements in this one. Okay. Now if A and B are disjoint means their intersection is 0, then you can straight away write this one. So that is a direct interpretation. Now A minus B can be written as A minus this one. Now properties I have explained after Venn diagram, so that now these are very easily understandable. Okay. Similarly, you can write this one as A minus B. So if I take from here, so what we can do, A, number of elements in A is number of elements only in A plus the number of elements in the intersection of A and B. This is a very useful property again for triplets. Now in triplets you can interpret like this one, that suppose if you are having three things, 1, 2, 3. Now here if you add A, B, C, so you can see that if I use the different color now, these regions, one in the green, they will be counted twice, right? And the middle one, which is still unshaded, that will be counted thrice. So what do we need? Now if I subtract the common part, now if I subtract the common part, this will be the shaded, this part, or let me just zoom it a bit basically, yeah. So if I am going to subtract this thing, the intersection of these two, okay, so basically what will happen, this will also get subtracted. Now if I subtract this, so you can just see from here that if you subtract one time this, then this one, and then this one, this will be subtracted 3 times. Now initially it was added 3 times, then it was subtracted 3 times. So middle part is gone. This is taken care of one time. This was taken 2, but now since we have subtracted, like written here, so this has been eliminated once, but we need to add the middle part, which is the intersection of all 3. So these are all very self-explanatory properties. These you can straight away apply from this thing, Venn diagram. Very easy to understand. Now again, set of elements which are in exactly 2 sets. Now exactly 2 sets, again if I look at this thing, exactly 2 means this part, and you subtract the middle part basically. If I want to, this part I want to subtract from all the things. So once you add the green part, it will be added thrice, right? So if you subtract this part thrice, you will be only getting the green part, only green. We need only green. So for only green, if you are considering 2 at a time, so this will be taken care of, so this will be extra, then again this will be taken care of, this will again be extra, 3 times extra. So that's why 3 times this is minus, so exactly 2 it will give. Now at least 2 will, now this is done for 3 times, this is same. The only difference will be here. Why? Now we want to include it one time. It was included 3 times in the original addition, so we subtract, if we subtract it 2 times, it will be at least 2. Basically this will also get included. Okay. Number of elements in which there are exactly 1. Now exactly 1, what do we need? Clearly if you add this one. Now whatever the times these people are added, the 2 and 3, that you subtract, so it will be removed. So as we see that this is added 2 times, so we'll subtract 2 times, 2 times, 2 times. Now remember the middle one will subtract with each of them. So it will basically be subtracted 6 times. So this was already added 3 times in this, subtracted 6 times, so we need to add 3 times to get exactly 1. Now these are again very easy. If you interpret, draw a big Venn diagram, see what you are counting in A, B, C. The methodology of A, B, C, D, this one will help you especially in getting these results too. So that will be very helpful if you apply that in this one. Okay. Moving on to some more properties on the sets. So these 4 again are very common properties. Any set union universal will always give universal set. Any set intersection by 5 will give 5 because 5 is nothing. So if you take common with nothing, it will be nothing. Now phi complement is universal set, universal complement is phi. Again, phi is nothing, opposite of nothing is everything. Everything means universal set. Universal set is everything, opposite of everything will be nothing. So that will be a phi set. Very easy to interpret and understand. Moving on to the next properties. Now these properties basically all are just kept for your revision, and so that these you can note somewhere, and once you get to the questions, then you have all the list of properties which you can play with. Practicing will help you to master these properties. Idempotent law. What does idempotent means? Okay, idempotent means that anything, any operation if you do by itself, so that thing means, so if you are looking for union, so it means you are doing that with itself, the set itself, so that will give you A. An A intersection, very clearly understand. Identity means you are getting the same, the output is the same as the initial one. So the basic one, if you look at here now, A union phi will be A. Now there can be a subset of A also which can be there, but the most basic set which will be 5, because if suppose if you take A as 1, 2, 3 and B as 1 and 2, then also you will get union as 1, 2, 3. But here we are doing it with the most basic set for which this property will be true. Similarly, if we look at intersection, now why universal? Because this is again the most basic commonly used set. Now again, if 1, 2, 3 would have been A and 1, 2, 3, 4 would have been B, then also this property would have been there, but this will be a variable thing, not standardized. When we are using phi and universal set, they are always standardized. Commutative law, this we have been doing from 6th class. A into B is B into A, that kind of law. So this is again understandable. Associative, same thing, ABC, ABC. So just the change of brackets that we have been doing, right? Now this is again self-explanatory, nothing to explain in that, just you have to remember associative. Distributive. Distributive is again gonna be interesting one. The commutative is easier one. Right now, again, like we did for, now think of this as multiply and this as addition. So 3 into 2 plus 3. How did we write that? 3 into 2 plus 3 into 3. The same way you're gonna do here. Take instead of multiply union, so A union B, instead of plus the inside one, plus the inside one is intersection. So A union C, like this. That is what is written here. Same goes with the intersection part, and if it's opposite inside, does not matter, same property you can. Now very important law which will be going to help you in solving many questions in boards as well as the question might come in JEE also. Now talking about the De Morgan's law again, like we did do for negation, the same goes for the complement. Like we have already done the complement in terminologies. So complement means like if you are having a set, okay, now this union, if I look at this, A union B. Now what it is actually, it's actually you are taking the complement of this. So this one, if I write it like this, the complement will be unshaded area, okay, because this whole is complement and its opposite will be. Now if we look at it like this one, okay, this should be in the next line basically. This is one property till here and this one is the second property, okay. Now let us look what is A dash. Okay, I'll use different shades to show this. Purple will work. So this is A dash, right? All of you agree with me? Now if there is another set present here. Now this will be a bit dark. Let me have a light color. Yeah, this is visible. Try to visualize the things. And what will be B complement? That is set B. Okay. So B complement will be all this part. Now you can clearly see if I take intersection of this thing, these two things. So you can clearly demarcate that these are the region where you're either getting only one shading or so rest all except this black one, everything is, so same thing we are getting in the Venn diagram. So De Morgan laws is something like if you are doing negation, we invert the sign, same thing we are doing here. If you are taking complement, so you will just make the sign opposite like that. Okay, same goes with the intersection. If it's intersection, then it becomes complement. This you can just pause the video and do yourself using the Venn diagram. Okay, moving on to the questions now, based on the properties which we have done. If A is given by this thing, x is equal to 3 raised to power n, and belongs to natural numbers, n is less than. So clearly n A will be 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, 3 raised to power 4, 3 raised to power 5 and 3 raised to power 6. This will be your A. And B will be, okay, so 3 raised to power 2n basically. So I can just make it as 3 raised to power 2, 3 raised to power 4, 3 raised to power 6 and 3 raised to power 8. Which of the following is false? Now you can just open it, check it yourself. This is again very easy. Now this sign is basically symmetric difference, that is A minus B union B minus A. If we look in the Venn diagram, symmetric difference basically represents symmetric difference of this basically, and union this one. This sign actually means this one. Okay, going for this thing A union B. A union B means 3 is there, 3 raised to power 1, 2, 3, 4, 5, 6 and this is 8. So this is true, not false. A intersection B is 3 to the power 2, 4, 3 to the power 6 and 3 to the power 8. And just check, this is 3 to the power 8. So this is also true. A minus B, which is this one, odd powers basically 1, 3, 5, also correct. Symmetric difference, union of these two. Now again this will have, we have to basically remove the elements which are common. So there should not be any even power. So this is 3 raised to power 1, 3 raised to power 2 here. Now this is not present anywhere. 2, 4, 3, right? 3, 4, 3. So this won't be present in this set. So this should be the right choice. Check it again, this one, like whether we have done all the things correctly or not. And this is not very difficult question, okay? Not a difficult question. Now again, okay, now this, okay, I got one thing, like this is not true. Why? Because this is not having 3 raised to power 8. So this is basically wrong, this B part. And here I was thinking, yeah, it should be misprinted. It's a 2, 4, 3. So symmetric difference will have all the even powers, or this thing odd powers. So yeah. So this will be the wrong answer, B. Basically, this is not common in both. This is 3 raised to power 8, which is not present in all the options. Moving on to the next question. Now this was an easy question. Just bit calculations you people can check yourself. Not a very difficult task. If A and B are two sets, then this will be equal to, okay, let me change the color since black is already exhausted. So blue will be, yeah, this is good. So A, now this is again same thing, the the law which we have distributive property, right? Think of this as plus sign, okay? This with this, union A intersection B, right? Now what is A union A? That will be A union A intersection B. Now if you can do it orally, it's very good, like it's clearly A only, but you can visualize it on the Venn diagram also. That A union A was this whole part. If you take the union of this one with this one, so that will be basically A itself, the set A itself. Not a difficult question at all. Again, just the simple properties which we have done, application of that. Okay, now this is a good question. This is actually a good question. Standard JEE mains question, I would say. I should have put it in previous year JEE questions because this is a previous year JEE, but this is for practice that how the questions will likely be. Now, perfect example of De Morgan's law here. First of all, we'll apply to this one, right? So A union B union C. Intersection, now this is again A complement union B. Now whatever things are there, like we have done complement of complement is a set, C complement will be C, right? So what we are figuring out here is that this is same, right? If you see here, this something as A union, if I say this as D, intersection A complement union D. So can we see this as a distributive property where we can say that this is basically nothing but A intersection A complement union D. Now this is nothing but D I can write it as B union C, right? So this is A intersection A complement, like intersection of this with the complement will be phi. So phi union D will give you D itself. So it will be basically B union C. Now this is a perfect example of all the properties being used, okay? This intersection with C complement. Now again you will have to apply the same thing. B union C distributive. This is very, very important. Like first I am applying this with this one, then keeping the sign as it is, then this with this one, C intersection. Now again this will be phi, so this will be left and this is right there in the option A. A perfect example to see. If you are not able to get it, again go for this strategy. A, B, C, D. This will help you surely to get this done. Okay, although it will be a bit cumbersome. Okay, but this will be helping you that A union B union C will be all these things. Intersection, if you want to intersect, so you can just take outside D and you just have to be good at calculation, which will make you do this one. So very, very good. I would say the most brilliant question of the questions that you have discussed. Stop once again, do it once more if you want to go back. This is very, very important step which I have discussed here and brilliant question I would say. So this is for this part, this is enough, like questions which we have discussed, the concepts which we have done. If you go thoroughly, this is the area where the questions in JEE mains can appear. If you have any doubt in this topic, you can post it for free on askIITian website. For this, just visit the askIITian.com and there you can visit discussion board. It will direct you to Ask Expert where you can select the category and according to the category post your question and click the Get Answer button. Experts at askIITian will answer your query within 24 to 48 hours. So this was it for the phase 1 of our journey. Sets, I guess, is very much clear to all of you. So in the coming parts, we are going to start with the relations. That will be the second major phase of our journey, and it's again going to be important for boards also, as well as we will be observing for JEE mains. Although in your textbook you might be finding sets as one, relation and functions as one, but we have integrated it here because the functions which you will be studying is a separate video that is specially made for JEE Advanced, because that is the most important topic for JEE Advanced. So functions will be taken in detail, but here we are discussing the sets and relations, and stay tuned for the relations.